So let's determine if this equation has one solution, no solutions, or an infinite amount of solutions. So that means I need to solve for x. I'm going to draw my line to keep my left side and my right side separate. And so first, both sides are really long, so I want to simplify. On my left side, I see that I can combine like terms. I have a positive 1x. Remember, if it's just x, there's an invisible 1 in front of it, and a negative 4. So 1 minus 4 is going to give me a negative 3x. They're different signs, so I subtract and I have more negatives. I'm going to bring down my plus 3 because I have no other constants to combine it with. Now, I see I have parentheses, which means I need to distribute to get rid of them. However, I don't see a number in front of the parentheses. So remember, if there is not a number, that's like there's an invisible 1 here. So I'm going to leave and just bring down this negative x and deal with it in a minute. I need to distribute a negative 1. This is where we have to be so careful of our signs. It's not just a positive 1, it's a minus or a negative 1. So negative 1 times 2x is going to be a negative 2x, and this is where we have to be super careful. A negative 1, this 3 is like a negative 3, and a negative times a negative is a positive. So it's going to be a plus 3. On the right side is still long, I can still combine. My left side is good, so I'm going to bring down negative 3x plus 3 equals, I see that I can combine like terms. I have a negative 1x and a negative 2x. Those are the same side, so I have one negative and two negatives. That gives me negative 3x plus 3. Now I can already start to see that both of these sides look the same. However, let's move the coefficient with the x to get to one side to really be sure. So if this is a negative 3x, I would add 3x to both sides. Negative 3x plus 3x, those cancel out and I'm left with 3. Equals, on the other side, the same thing. Negative 3x plus 3x cancels out and I'm left with 3. So at the end, since my x cancels out, I'm left with 3 equals 3. That is a true statement. 3 is always going to equal 3. My left side is balanced with my right side, so that means there's an infinite number of solutions. Any number I choose can be plugged in for x, and my left side will always balance and equal out to my right side. So same thing, we're going to determine if this one has one solution, no solutions, or infinite amount of solutions. So the first thing I need to do when I see this big fraction is I need to get rid of the denominator. So equations, we're always using inverse operations to get rid of numbers. So on the left side, if we're dividing everything by 3, the opposite of multiplying, or opposite of dividing, is multiplying, which means to get rid of the denominator of 3, I need to multiply both sides times 3. And remember, when I do the inverse of something, it cancels the numbers out. So I'm not multiplying the numerator by 3. Just multiplying by 3 means these 3's will cancel out, and I'm left with the numerator. The whole point of doing the opposite, or the inverse, is to get rid of that number. We don't multiply it by the numerator. Now on the right side, we have to be really careful. I'm multiplying the entire right side by 3. So this is kind of like distributing. I'm not just multiplying the 9 by 3 or the x. I'm multiplying everything. So that means I need to multiply the 3 times the x, which gives me 3x, and the 3 times the 9, or the negative 9, which gives me a negative 27. So again, if I'm multiplying both sides, I'm multiplying the entire side, not just one of those numbers. Okay? Right now I do see same coefficients, but I'm going to get rid of it just to see what's left. So if it's a positive 3x, I'm going to subtract 3x on both sides. 3 minus 3x cancels out, and I'm left with a negative 9 equals, again, 3x minus 3x, that cancels out to be 0, and I'm left with a negative 27. Now here, if I read this statement, it says negative 9 equals negative 27. That is not true. So in this situation, my x's would always cancel out, and I would be left with this statement at the end. Negative 9 equals negative 27. This is not true, so there are no solutions to this equation. There is no number that I can plug in for x that would make this equation balanced, where the left side is the exact same as the right side.